Welcome to InterviewPro. In this video, let's try to solve a LeetCode problem to find the majority element. This question was asked in a number of companies. The problem statement says that we will be given an array of size n and we should return the element which appears more than n by 2 times, and the element always exists in the array. Whenever there is a question to find the majority element, we should recollect an algorithm called Moore's voting algorithm. This algorithm assumes that the first element in the array is the majority candidate and it maintains a count. As we already have one majority element, the count will be 1. There are 3 rules which drives this algorithm. If the count is 0, we have to set the current element as the majority element and increment count. If the current element is equal to majority candidate, simply increment the count and proceed to the next item in the array. If the element is different from the majority candidate, simply decrement the count. Let's go through each and every element in this array. So our second element is 2, which is similar to the majority candidate. So we'll simply increment the count. The count value is now 2. Now, if we move to the next element, the value is 1, which is not equal to majority candidate. Then what is our rule? If the current element is not equal to candidate, we'll simply decrement the counter. So previously the count was 2, now it is 1. So array of 2 is not equal to majority candidate, so we have decremented the count. Next, the element is 3, which is not equal to majority candidate again. So we'll simply decrement the count. So count is 0 now. When we go to the next element, the count will be 0 and majority candidate will be set to the current element, which is array of 4, which is nothing but 1, and also count will be incremented. Previously count was 0, now the count will be 1. Let's move to the next element. This element is not equal to the majority candidate. So the count will be decreased from 1 to 0. When it comes to the sixth element in the array or the sixth index of the array, the count was 0. What is our rule? We have to set the current element as the majority element. So now the majority candidate will be 2 and the count will be incremented to 1. If we move to the next element, the value is 3, which means current is not equal to candidate. So we'll decrement the count. When we are at the 8th index, the count is 0. So what are we supposed to do? We'll set 1 as the majority candidate and we'll increment the count. So the count will be incremented from 0 to 1. Again, the 9th index has a value 3, which is not equal to candidate. So we'll simply decrement the counter, which makes it 0. For the next element, the count is 0. So the current element is set to the majority candidate. So what is the majority candidate now? Array of 10, which is 1. And the count will be incremented to 1. Now, if we move to the 11th index, it is similar to the majority candidate. So the count will be incremented from 1 to 2. Same with the 12th one as well. Now the count will be 3. We have reached the end of the array. And what is our final result now? Majority candidate is 1. But let's make sure if 1 is really the majority candidate. What is our condition to consider an element as a majority element? It has to be greater than n by 2 time. Means it has to appear in the array for more than n by 2 times. What is our n value here? Size of the array. 12 plus 1, 13 by 2, which is 6. But how many times did the number 1 appear? 1, 2, 3, 4, 5, 6, 7. 7 is greater than 6. That means 1 appeared more than n by 2 times. So our majority element is 1. This algorithm may not always return the correct majority element. For example, let's go back to index 11 and let's assume that this is the last index. So what is our majority candidate? 1. And how many times did 1 appear? 1, 2, 3, 4, 5, 6. Because we don't have this now, we are assuming that 11 is the last index of the array. In this case, 1 appears only 6 times, which is not greater than n by 2. It is simply equal to n by 2, but not greater than n by 2. So we cannot consider 1 as the majority element. So when you use this algorithm, in this question, they have already mentioned that majority element will always exist. So you don't need to double check this. In case this condition is not specified, we have to make sure that the element returned by the algorithm is the actual element, actual majority element. So in our case, 1 occurred 7 times. Hence, 1 is our majority element. So how this algorithm is working is, initially we assumed 2 is our majority element. Then we saw 2, so we incremented the count, which made the count 2. Then we saw a element which is not equal to the majority element. We decremented the count became 1. When we saw another element which is not equal to the majority element, we decremented the count again. When we reached the index 4, the count was 0. So we assumed this is our new majority element. So why did we do this? If you consider only this part of the array, 2 occurred twice, which is equal to half of the array, and other half of the array are different elements, which is not 2. So this is definitely not a majority element, right? This occurred only n by 2 times, which is not greater than n by 2 times. So 2 is not the majority element. We'll assume whatever element is the current element, that is a new majority element, and we won't consider this previous array. We'll ignore this previous array and we'll start fresh from this index. Now again, if this is 1 and I saw another different element, so I decremented the count. When I go to this, the previous array, which means the index 4 and 5, 1 occurred only n by 2 times. In this array of size 2, 1 occurred only half of the times, which is not greater than half of it. So this is cancelled. We'll assume 2 is a new majority element. The same thing happens when we reach the element 8 and when we reach the element 10. And after that, we don't have any other element. So in this array, 10, 11 and 12, which is of size 3, 1 is occurring more than twice, which is greater than n by 2. So this is going to be our majority element as per this algorithm. But always make sure that this one is the actual majority element, because considering only these 3 indices is not enough. We have to check the complete array. So always double check that the element returned by this algorithm is the majority element. Now let's see how we can write the code for this. This is our question. I'm writing the code in C# language. So what did we discuss? This algorithm always assumes that the first element of the array is the majority candidate. Let's declare a variable. I'll simply call it candidate because majority candidate is going to be a big name. So nums of 0 is the first element, which is our majority candidate as of now. And I'll initialize the count with 0. We have to loop through each and every item in the array. So for loop int I equals 0, I less than nums dot length, I plus plus. What is our first condition? If you remember, we said that this algorithm is going to follow 3 rules. What is the first rule? If count is 0, then we'll simply make the current item as the majority candidate. So our candidate is going to be nums of I, and count will be incremented. You can increment or simply assign it to 1 also. And what is our second condition? If the current element is equal to the majority candidate, we'll simply increment the count. So what is our current element? Nums of I. If this is equal to the candidate, we'll simply increment the count. And what is our third case? If nums of I is not equal to candidate, we'll decrement the count. So I'll simply decrement the count. Finally, we'll return the candidate. So this is because the question states that the majority element always exists in the array. If this condition is not specified, we have to add one more condition. Let's first try to run this and see if it works. So these test cases are passed. Let me submit. So this question is submitted. Now let's try to add a condition. So what are we trying to make sure here? That the candidate which is returned by this loop is the actual majority element or not. And what is the condition for it? That this candidate should appear more than n by 2 times. It should appear more than n by 2 times. So let's take another count variable. Let's say count 2. I'll initialize this to 0 and loop through all the elements of the array. J equals 0, j less than nums dot length, j plus plus. If the current element nums of j is equal to candidate returned by the above loop, will simply increment count to plus plus. And once we get the count, check if this count is greater than n by 2. What is n here? Nums dot length by 2. If this is true, we'll return the candidate. If this condition is not true, we'll simply return -1. So let's run this again. All the test cases are passed. Let me submit. You can see that this is accepted. So coming to time complexity, we are looping through every item of the array. So the time complexity is going to be big of n, and we're not using any additional space. So the space complexity is going to be big of 1. I hope the concept is clear. If you like the content, please like, share, and subscribe to InterviewPro. Thank you.